I'm thrilled to introduce Specmatic Studio, a no-code visual interface built on top of the powerful Specmatic engine. It is designed to help cross-functional teams, not just engineers, redefine how teams ship better APIs faster and contribute to the overall quality and governance. Today, I'll walk you through Specmatic Studio and how it's simplifying contract testing, API mocking, resiliency testing, backward compatibility testing, spec generation, and more, all without writing a single line of code. So let's dive in. This is the initial interface for Specmatic Studio. We will see a set of specifications that are already loaded here. But before we jump in, let me quickly set the context of what project are we going to be looking at so that you will understand what I'm going to explain. Some of you might be familiar with this demo application that we have shown before. I have an order app which is going to make a request to an order backend for front-end service, which in turn is going to request from the order API, get a response back, log the response onto a Kafka topic, which will be used by analytics service, and then respond back to the order app. So this is the context, and what we are trying to do is we are trying to test the order BFF, which is here. So let's quickly jump back to Studio. So as you saw, we depend on Kafka, which is one of our dependencies. So let me quickly start a Kafka mock right from within here. And there we go. It started on 1992. Next, what I'm going to do is I'm going to load the BFF specification. As you can see, this specification has three paths: find available products, orders, and products. And we can see the methods and the response code. Right now, there are no examples that are generated. What we are really interested is in testing whether the BFF adheres to the specification. So the BFF itself is running on order BFF on port 8080. So with that, I'm just going to point to it and run the test. There we go. We see the tests are running. And what do we see here? We see we have a failure. Why do we have a failure? It's saying basically slash orders is not implemented. However, it's saying that slash orders is also missing in specification. What's going on? Oh, you notice there is a small typo and looks like someone's misspelled in the specification. So no problem. We can quickly jump here to the spec view and we can go and fix this particular problem. So let me quickly make that change. Let's hit save. You'd also notice that we have a test backward compatibility button over here. This is to basically make sure that the changes that we do are backward compatible. So sure enough, that is good to go. So now let me come back and just rerun the test. And that's cool. So now we don't have any failing tests, which is great news. We have only the 200 covered, as you can see. And we also see that slash health endpoint is missing in the specification. Of course, we don't want to put this in our specification. It's only for internal consumption. So I'm going to exclude this from the specification. Okay, perfect. So we know that at least for the Happy Path 200 scenarios, the BFF specification and the BFF implementation are in sync. There is no API drift at this point. So whatever drifts were there, we kind of fixed those. Now let us turn on generative tests. For those who are familiar, we are able to now test the 400 scenarios as well. So let me just quickly run that and see what happens. And sure enough, we see 74 of the tests have failed. Why have these failed? Let's quickly go in here and see. So it says the key named message in the response was not in the specification. Oh, looks like we have another API drift here. So if we go to the specification, what we see is we have something called path, while our actual service is returning message. I think message is correct. So I'm just going to go ahead and update this, save. Let's come back and let's rerun all the tests. Okay, great. So we have 89 tests passing, and so now you will see that our coverage is also slowly increasing. So we have both 200 and 400 response codes are covered. We don't have 503 response covered so far. We'll get to that in a minute. Let's look at how do we cover the 503 scenario. So what is actually happening in the 503 scenario? So essentially think about the BFF is simply a backend for frontend for the actual order API. And if the order API is taking a long time to respond, we don't want the BFF to be waiting, right? So we want the BFF to time out and return a 503 response. Now, I want to simulate that situation where the underlying order API service is not responding within the defined timeout scenario. So, first thing we will have to do is we will have to generate an example, okay, for the 503 situation. So, I'm going to go ahead here and I'm going to generate an example, okay. Let's quickly jump in and see, okay, we have a slash find available products, a get request. And I'm going to try and put a type called other. So whenever we're going to pass other, we would expect that the downstream service just does not respond in time and times out. So we would expect a 503 to come back. Let me update that. And we would expect a timeout error. Order API did not respond back in time. Okay. So I've made some changes. Let me quickly save and validate if the changes that I've done is fine or not. This interface you might be familiar. This has built-in validation and linting for examples. If I went ahead and made a mistake over here, you would immediately see that that would complain. So for status code, which is a number, but if I went ahead and changed this to, let's say, a string, let's save and run this, and you would see immediately that it is complaining that this was expected a number, but was something else. So this is all the built-in validations that are easily accessible. Let me change that, and sure enough, it is working. So what we have done is we've added an example for a 503 situation. And now let me go back to the test and run all the tests. So with this example added, you should see that this is running and now this test is failing. It's basically complaining that I expected a 503 response, but I got an actual 200 because the downstream service is obviously immediately responding at this point. So how do we simulate a situation where only for this one scenario, the downstream service times out, does not respond on time, but for all the other scenarios, it works fine. For this, we won't be able to actually rely on an actual service. Instead, what we would like to do is we would like to mock the service so we can do fault injection and test these kinds of scenarios. However, to mock the service, we would need a specification. And as you can see, we don't have a specification for the order API. What can we do? Well, what we can certainly do is we can record a specification and make sure that we capture the traffic that is flowing through. So what I'm going to do here is I'm going to put HTTP order API, which is running on port 8090, and I'm going to proxy that through a port 9090. So this will mean whatever traffic that is going to order API 8090 will first hit 9090, get recorded, and the response also will get recorded, and then finally we will generate a spec. So let me just start this proxy. Sure, the proxies got started. However, right now our BFF application is directly going to go to 8090. Instead, we want it to go to 9090. Let me quickly jump here and make that change. So we want the BFF to look for order API on 1990. Okay. With that change, let me quickly restart the service. And let's come back here. We should be able to run the test and see the exact same results as before. So let's do that. And yeah, so 89 tests were passing, one test is still failing. When these happen, let's quickly go to the proxy and see. What you see here is that we have recorded all the requests that came to the proxy and then went to the order API. However, we were able to capture all of this. Now let me stop the proxy. And as soon as you stop the proxy, you will see that we actually generate the API specification along with the examples for it. So all the examples have been nicely generated here. Let me now quickly jump here and start this on the same port, that is 1990, on which the proxy was running. And let's quickly go and see what's happened on the mock that we just generated. So you can see that it's recorded a whole bunch of requests that have come through. What's happened? It's basically captured what was the request that came in and the response it sent back. So that is great. The mock is working perfectly fine. And of course, all our tests are working same as before, 89 tests and one failure. The one test that is still failing, of course, is where we want to simulate a timeout situation. So let's go to the proxy now. And what we really need to do in the proxy is we need to add a new example, something of this nature. Whenever it's type other, we want to basically introduce a delay in seconds, and we want to say take 5 seconds to respond. So let's validate and save this example. That's great. It all looks good. So let's go back and rerun the test. And it's just taking a little second, and there we go. You see that 90 tests have all passed. This particular 503 test is also passed, and you can clearly see here that we were expecting a 503 response, and we in fact did get a 503 response because the downstream service timed out. So this is a quick demonstration for you in terms of all the different capabilities that we have in Studio, from running contract tests to basically running a mock. Both you saw a Kafka mock and an HTTP mock. You also saw how we were able to generate new examples, change the examples, introduce delays for fault injection. And you also saw how we were able to use the proxy to generate a specification itself. So that's Specmatic Studio, right? Bring the power of contractor-driven development to your entire team. Download it, explore it, and start building better APIs faster.